Okay, hello again. I'm gonna start the video. So welcome back. I'm just gonna give you guys a few minutes to get everyone in here. If you haven't seen me before, start the video. So welcome back. Oh, I had the YouTube open, so I started hearing myself, which is not something you want to hear. So if this is the first time seeing me, you should go to the last live stream because we went through intro 1. And now we're going to go through intro 2, which is we're just going to pick up where we left off. I'm going to wait a few minutes for anyone else to join, and then I'll share screens again. So I see some people saying hello in the YouTube chat. I'll try to look at that this time, although maybe not. Okay, so I see the circuit we had before. I'm going to share screens now. If you have any questions, let me know. Okay, welcome back. So this is where we were, and I believe we got down to take a break, but we were still here, analog read. So we just covered digital read, which is where we use the push button to turn on the thing when you clicked, and we kept track. Now what we're gonna do is we're gonna go over and we're gonna talk about analog read. So a little recap, the push button worked because you almost gave it power, but it didn't actually connect until you pushed it. When you pushed it, it knew that, oh, okay, well, it just connected the metal. And because of that, it passed through. And when it passed through here, there you had essentially a parallel circuit going down to your digital input because you pinned it as input. And what you want to do instead is now I want something where instead of giving me a digital, I want it to give me an analog, which I want to have more values. And for that, we're going to use these ones. So you can see down here, there's an analog in. The only difference really is you can tell these that they're input or output. And there's the PWM in order to send out analog. Like it can give different amounts of electricity. But when you want to receive different amounts, that's not just detecting like a lot or a little. You need to use these ones just because like the way it's set up, like it'll give you weird values if you put it in here. It'll still give you some values, but it won't know how to read it that well. Okay, so what we're gonna do is we're gonna go over here and we're gonna set that up. And what we're gonna use is something called a potentiometer. I don't know if I said that right. Okay, breadboard here. And you'll notice like some of the things, like I'll be asking you to make an LCD later. Don't just take this one because it's kind of gonna be confusing. They do like the full wiring. So just start with this all the time and work your way through what you know. If you have questions, you can tell me. I'm just moving to see if I can see the chat at the same time. All right. Just a second. Okay. So instead of a button, we want this thing. And this is essentially, it is by itself, like, has resistance. So you don't need to actually put another resistor. Like, you know how we've been putting these? The potentiometer itself is just a giant resistor. You don't have to change the value too much. Like you can make it 10K, that's pretty common. It doesn't really matter. Because what we're doing is as you're alternating this thing, like in real life, it's like, you know, you're spinning it. As you spin it, it changes how much of the electricity is flowing through, right? It's essentially it's a big resistance. And what you do here is you connect to it like we've been doing before. So it always has power. And it always, what's it called, returns, and you just want to read how much it's giving you. And you can read by connecting this to the, let me just scroll down a bit. You read by this middle one. So you can see there's the terminal, and the middle one tells you the analog. Okay, so it's a basic setup, I think. I'll just color the screen or something, because I think we did that earlier. Move to text. And in terms of coding it, it's again very similar. So if we go back to the digital read, analog read, it's the same thing. You're still setting it up as input, but now you just read. Oh, do we not need to set it? You might not need to because it's A, but I would do it anyways. So you can still do, like these are A0, A1, you can still do it here, I believe. So you could say denominator pin. That will be your A2. And you can pin that to be input. And then let's just do the serial again. Dot begin. And we're just doing 9600. Again, that's just a way to communicate to your computer or whatever you're using to connect. And we're going to print out the value of that. Now, to get the value, we're going to do that thing again where we read. And we're just doing, instead of digital read, we're doing analog read. And I actually think you don't need to pin it if it's in one of these, but it's fine. It's better like just to always pin so you know what's being used. And you're just reading from this pin. You're going to print the value, and then we'll wait a second, okay? All right, so we're just going to run that, and let me know if you have any questions. You can see it's at 0 right now. It's all the way down, and I'm printing every second. Now I'm going to move it up to like the middle. And in terms of the value of the potentiometer, it's from 0 to 1024. I think so, at least. Where is it? This is the analog read, which is between yeah, so 0 to 1024, and it's not just 0 to 255 because that's what you send. Okay, does this make sense? It's what we've been doing before with the button, but instead of just detecting whether or not there's power, because the way the button works is by connecting the same way we talked about the flashlight, what we're doing instead is just detecting how much power it's letting through. And a potentiometer is just a giant resistor essentially, and that's how it controls it. And by reading it, we can have some values, and we can use that to control other stuff. Is everybody okay with this? I want like some thumbs up or something, so I know that we're not all sleeping. Okay, that's good. So now we're gonna go back. I'm just moving the chat around. If you ever see my mouse dragging things without showing you what it is, it's because I'm trying to keep track of this. It's just weird because the way Zoom handles like the camera, it like gets put behind the chat, but I'm trying to put it on top, so I just move it around. Now we are here. So let me give you guys a task to work with first so that I can do less work. So we did the potentiometer with the print. I want you to take this and make it control a light. So just like how we had a button control the light here, where we controlled whether or not it's on or off, I want you to control the brightness of it using the potentiometer. So instead of digital read and digital write, I want you to use analog read and analog write. So give that a go. Just do keep in mind the different values. So instead of 0 to 1024, it's 0 to 255. So you have to do some conversion. Let me know if you have any troubles. I'm going to give you guys about 5 minutes for that, and then we'll work through it. And then for those of you that get it done early, you could look into the RGB LED ahead of time. We'll get into that. Or if you do want to set up like mix the thing like a button with a potentiometer, you can do that as well. Okay. Let me know if you have any trouble. All right, no one seems to be texting in chat, so I gotta check on you guys again. Give me a thumbs up if you got it, a hands up if you have trouble, or if you're still working on it. Or text me if you have like a more specific issue you need help with. see, the number of thumbs and hands needs to add up to 14, but I'm guessing it's only going to add up to like 5. So do react, guys. Okay, for those of you that lost the link, I'll send the link for the slides again. But I do think you should be able to figure out the circuiting for the lights on your own by now. If not, do look it over. I'll send it. All right, let's check again. Thumbs up if you're done, or if you're good to move on. You want me to take it up. Otherwise, if you want me to wait for you, give me the little high five. Yeah, there seems to be about a 50-50 split, so we'll just wait a bit more, a few minutes. Let's say 2 minutes. All right, team. So we're gonna take it up now. So you can put your hands down. If you haven't got it working, that's fine. Just follow along, because I want to walk us through this and go to what is supposed to be like the second part, because this is meant to be before the break. So to wrap up how analog read works and extend, we're gonna take this and use it to set the what is it called? We're gonna clear the output here because it's been running for a while. We're gonna use an LED and set its brightness to be based on how much this is set. So let's turn on the LED. Okay. And again, we're just going to ground it at the end. So we're just going to set that up right away. And before we turn it on, we're going to have it run through a resistor. So by now you should be familiar with setting it up with 220. And you can see like it changes the colors of it. So it's pretty useful if you want to like grab it in real life, if you're looking for one, or if you have the kit. I don't think they sent the kits this year, unfortunately. And then what we're gonna do is we're gonna keep it. Remember the PWM, like, or the squiggly ones. These are the ones we can send like a variable amount of electricity. So instead of just 5 volts, we can tone it down and it'll change the brightness that way. And I'm gonna color this red. Just a convention, doesn't really matter. Okay. I'm gonna close the participants chat now, but I need to keep the chat open. So just give me a second. Okay. Now let's go to the code and change this up. So we already have it reading how much it is. All we really need to do is have another pin for sending to the LED. And we have that on 11. And again, we're just gonna pin that as output. So it just bugs me that A is not above, so I'll move that around. Okay. Now we have this pin, and all that's left is to write to it. So we read the value, and instead of printing, I mean, we'll print anyways, but what we want to do is we want to change the value of this light, which is just, instead of digital write, it is analog write. And again, if you're ever having trouble, where is it? Right before the break, that's where it is. Like I put the code here as well for the other one. I guess that's just the thing. The analog write is up there. Anyways, analog write, you will give it the pin number, and it's on a PWM, so it's fine. And you give it the exact number. So that'll be 0255. This thing is 0 to 1024. So for now, let's just do a divided by 4 and see what that gives us. Okay. Now divided by 4. We'll print that value, and we can even print the exact brightness instead. And let me know if you guys have any questions on this, or if it works a little unexpected. So I'm going to turn it off. So you can see it's off now. I'm going to turn it on over here. Why do you guys notice, like if I go all the way off, why does it take a second to go down? Why is that? Text in chat what your answer is. Like if I go through this, it just changed to this. It didn't go all the values in between. Why is that happening? Yeah, so the delay is too long. So the thing is, when you have like a long delay, you can read the values, but it'll kind of clog up your thing. It doesn't matter if you spam it, like you can spam it, but it would rather be waiting for 10 milliseconds. And again, you can make that a variable so you can change it better. And that way, you can see as I move around, it changes the brightness. Okay. So this is just connecting what we know. It's actually simpler than the button because it's just analog read and analog write. And I just want to make sure everybody is okay with everything we've covered so far, so we can go on to the challenges or practices, because you guys are doing challenges throughout the week. So circuits, Arduino programming, digital and analog output, and then digital and analog input. Is everyone okay with everything? If not, this is when you speak up. And I'm not sure if it's worth checking the YouTube chat for that, because most of you are in here. If there are questions in the YouTube chat, someone could let me know. Okay, I don't see any questions, so we're gonna go on here. So you took the break, nice break, welcome back. So what we wanna do now in this part is I've covered the basics, and all that's really left now is for you to try the components yourself. And to get that, I want you to get more familiar with combining things, and then the next step is learn on your own, and then we'll take it up. So for these two practices, I'm gonna give you like 10-15 minutes to see what you come up with. And you can go to the next slides if you're done early. And then I'm gonna walk you through how we would approach this, okay? So practice 1, just combine what we know, make a potentiometer, control an LED's brightness, and then make the LED only turn on when a button is pressed. So this is sort of the 2 different exercises we've done. I want you to combine them. And then once you get that, I expect to be able to do that based on what we have here. Or you could, you can rewatch the YouTube if you get lost. There's the 2 links you should have. We can post it in announcements if you don't have it. And after that, I want you to add a second LED that's only on when the first LED is off. And then make it have the opposite brightness. And then if you want to go another one, while it has the opposite brightness, it also turns on and off on its own all the time. So this is just like different steps for you to keep you busy. And then instead of doing that when the button is held, you can make it when the button is clicked, which is what we sort of did earlier in another one. So these are all the different things. I want you to just see how much you can put together, and the wiring might start getting a bit messy, and that's the point. I want you to be able to organize it, okay? So I'm gonna mute myself. Any questions, let me know. Rewatch the YouTube for different parts or ask some questions, and I'm gonna give you guys 10, 15 minutes to just work on this, and then we take it up. All right. Oh, I should put my camera back on. Where are we? Hello again. It's been 5 minutes. I wanted to check how we look doing. Let's see. Give me a thumbs up if you finish this first part. Make the LED only turn on when the button is pressed, and that is controlled by some potentiometer. Thumbs up if you got that far. Thumbs up. All right. Thumbs up if you have this part working. So you have a potentiometer that controls the brightness. Just go to zoom. There's like the react button. Give me a nice. And if you're still working on just these first ones, give me the high five. Okay. So I'll give you guys the other 10 minutes. Just want to check in. If you guys do have questions, just send it in chat. I can help you along. That's why I'm here. All right. Good luck, guys. Okay, I'm back. Hopefully you missed me again. Let's see how far we are now. So this is the 10-minute mark. If you're not done, keep working. I mean, there's a lot of steps, so you can always keep working. Let's see where we are. Can I get a thumbs up if you're done the first one? Make a potentiometer control an LED's brightness. Right, if you haven't got this one yet, you try to just make sure you can like copy this over so you can start working on the other ones. Now let's see, can I get a thumbs up if you got to the second one? If this is what you're working on, give me a high five. If this you got working, give me a thumbs up. Yeah, someone's clapping. I don't know what the clapping is for, but thank you. Take that as a praise. And then someone give me a thumbs up if you're working on the bonuses. Okay. If you've done everything, you can text in chat that you're done everything. I mean, I feel like I put enough in here to give you another 3 minutes worth of work. And then after that, we'll take it up together. The point of this like second workshop is just to get you playing with it more. And I'll give you a little more freedom at like the end. It's split up to like 1 hour and 1 hour at the end. Just because that's what hardware is, like until you get to a more complicated level where you're working, like maybe if you're in the robotics or whatever. I don't know if they're still doing robotics. Do you guys still have robotics over there with like COVID going on? Because we used to have like the competitions and we like had to come together, build the robot and program it and so on. Oh, you do? That's nice. I thought it was like stopped for a bit after we left. But yeah, at this level, when you're working with just the Arduino, it's just getting the hang of it and then trying all these different components so that you can, you know, combine a bunch when you're making some robot or something for your challenge. All right, I'm gonna give you guys another minute and a half, and then I'm gonna start taking it up slowly and thoroughly, hopefully.
Okay, I'm gonna put the code for the points for attending the workshop in the chat.
Okay, let's take it up together now. For those of you that missed it, we got the points code in the chat, so just go to Discord, put that in. I forget the command, but you get some points for being here. Hopefully that's not the only reason you're here. So let's walk through this now. Okay, so first thing, make a potentiometer, control an LED's brightness. This is what we have here. So I guess I never stopped the simulation because I hate electricity. Let's see. There you go. Works fine. This is the code. We went through this, so I'm just going to assume we got this. If you had trouble with this, just look at the wiring in the code, see what you had different. The wiring could be a bit different, but its potentiometer is usually the same because it's by itself. It has a resistor. Like we can put 10K here. Maybe you put a weird value in there, so on. Okay. Now, again, this is just the code for using the syntax. Like we want to use keyboard and mouse when you connect it to a USB, so on. You can also notice there's references, which just read into it if you're interested. Okay. Let's go here now. Let's make it only turn on when a button is pressed. So this controls the brightness, and then another button controls if it's pressed. Well, what did we do here? Well, we had a button that when it's held, redirects, like we read that, and then we can actually, I'm trying to see the code we had here. If you look at the code we had here, it was, we pin it, and then, oh no, this is the old code. Like technically newer, but here. We made this one based on clicking instead of holding, but it's the same idea where you can read whether or not it's held by reading the button pin there. Okay, let's go here now, and let's create our challenge. So let's start from scratch. And if I am confusing you at some point, stop me. I'm just trying to move the camera around. Okay. Now what do we need? Well, we need a potentiometer because we want to be able to control the brightness of the LED. We need a button so that we can turn it on and off. And then we also need the actual LED that we're going to be, turning on and off and controlling the brightness for. So the LED is probably the simplest wiring, so let's just get that out of the way. And I'll just do like a resistance down to the bottom. Okay. So this is just 220 right here. Okay, so this is as long as we connect it. And we want to be able to give it different amounts of power. That way, we're going to connect it to a PWM pin. So that's the 11 right here. Oh, that didn't connect. There we go. Okay, right here. I'll just move that like. Just trying to move that so that you can see the different ones. Okay, so now we need to make these work. So how do we turn this on? Well, this one is already by itself a resistor, so we don't have to do anything else. I'm just trying to select it to change. Let's do, okay, let's make it 10K and let's turn it on. So we can always have it on. So let's just give it power. And again, it doesn't matter, like it doesn't always have to be aligned. I just like aligning it because it looks prettier that way. Black. And we want to read whether or not this is actually happening. And again, it goes to analog in, so I'll just do it all the way down to read. Okay. The last thing is we need to be able to read from the button. And like we remember, we have the, hold on, how did we wire it last time? I wanna, because again, there was a few, as I mentioned, like there's a few ways to wire the button, and you can use something like other than just labeling it as input. You could control it to control the default state. Well, none of that matters here. We just want to wire it in this way and just get used to it for now like this. So what we did last time is I just had it always on. And then when you click it, it'll connect back to the resistor down to the ground. And then at the same time, you were also just reading what is happening here. Okay, so let's just do that again, but over here. We are going to turn it on. So again, this is just 5 volts. And if you remember how we talked about circuits, like all of these are getting 5 volts. The actual amps depends on how much, just what else, like it's what is it called? Proportional to how much resistance is in that path. So we're going to turn it on and we're going to turn it off, resistance. And we're going to put 10K on this one. Although I don't know if it's good to have all these resistances lead back down to this. I guess it should be the same, should be fine. Oh, this is 10K, so it should stay here. Okay, and all we want to do is we want to read from this, so we're gonna put it at somewhere we can read. Well, I'll just put it here for now. And again, any of these will work for reading because it's digital, it's not analog, so you don't need to use the squiggly. You're free to use the squiggly, it doesn't matter. Okay, so now this is wired. If you have any questions about the wiring, let me know. We just give it power with the red and everything is always on, with the exception of the LED because we want to control how much power we give that to turn on the brightness. We're reading the, like whether or not the button is clicked on 3 and what the value of this potentiometer is at A0. Good so far? If you have any questions, just let me know. So we want to start by making variables for the thing. So what is it called? Let's just do from left to right. The LED pin is 11. The potentiometer pin is A0. And I'm just using int, like A0, like technically, the way it works is that's just another number, it's just labeling it weird. So you don't have to worry about that too much. And then the button is, push button is 3. Now we're just gonna put that in. So the LED is output. And then the other 2 are input. If I could spell, that would be great. Button, we want to make the read the button and the potentiometer. And again, since this is just an analog, like one of these, like it's going to be input, but it's good to just reference it here. Finally, go down here and let's read. So how do we access this? Well, we know that to send a power to the light, the LED, we can do analog write, give it the LED pin, and give it 10 or 255, like 0 to 255, right? And we know that to read from the potentiometer, we can just do analog read potentiometer pin, and that'll give me something from 0 to 1024. And I know that I can do digital read the button pin, and that'll either give me 0 or 1, low or high. Does this make sense? So what we want to do is let's do the first part. Let's ignore the button for now, just recreate what we had there. The value, the brightness is we're going to read the analog read. okay? And after we read it, we actually want to just divide it by 4. Because remember how this is 1024 and this is 255. Let's just do 4 to make it simple for now. I don't know if someone is unmuted or I thought I heard something. Someone have a question? No?
Oh, sorry, I forgot to.
Yeah,
I
no
think I
worries.
accidentally muted myself.
No worries. Okay, so now we have, this is the brightness. And then after you get the brightness, so you read it, it is between 0 and 1024, you divide it by 4. You can set the brightness. So we're gonna do analog right, the LED pin, that brightness, right? So now we're not doing the button. So we're just gonna comment that out. Comments are like this. And that just means it's not doing it. And I'll just add a delay of 1000. Doesn't really matter. So just 1 second. Let's see if there's any problems with this. So if I turn this on, there you go. You can see it's like half bright. And then I do this, after a second, it'll go like full brightness. Yeah. Does this make sense so far? We just recreated what we had before, but added a button for the wiring. Okay, great. So now what we're gonna do is we're just gonna stop this and I'm gonna add the last thing, which is int it's being held if we can read, again, just this thing. I'll just, a little bit easier to type it, but yeah. And if, I don't know why it went all the way there. Oh, it's because I didn't close it. If it is being held, then we want to do it at that brightness. So we're just gonna do what we were doing before. Otherwise, it's not being held. And you can do this like you could always do some funnier things in C++, but this is just the if statement we're using, and we're just doing 0. And you can do digital write low. And then if you want it to be more active, we'll make it down to 10, and now we'll start the simulation. So here it's all the way up, but it's not on. I hold it, and it's on. I let go, it lets go. Click, let go. And then I can change how much it is, and then do it again. And it should be less. Is that less? I can't even tell, honestly. Analog brightness. So if I do 0, then even if I do this, it'll be, yeah, nothing is on, right? But now if I change this all the way up, and there you go. Looks good. Any questions? So that's this right here. And now I'm just gonna go a little faster on the bonuses, and you guys let me know if you have questions. Are we good? Give me a thumbs up if you're good so far. Oh, I'm getting more thumbs up this time. Good. Okay. If you guys have any questions, let me know. Let's keep going now. We get to this part. Add a second LED that's only on when the first one is off. So it's just different, right? It just doesn't like the other one. We can do the cop joke again because, again, we're funny. Where is the LED? So now let's do, I don't know, maybe like Christmas, because trying to click this. Why is it not showing it to me? There we go. Let's make it green. So, Christmas lights, because why not? And same thing again. So I'm just gonna copy this resistor, 220 ohms. And remember, this is the cathode. So if you remember our diagram before, it goes through the anode, out the cathode. So this is the anode, which is the positively charged. I know some of you got that wrong in the Kahoot, or maybe the wording was wrong, I forget. And all we're doing is connecting this to a different pin. I'll move this over to here. Let me just avoid confusion so they don't like intersect. Oh, I love Tinkercad. Okay, so let's move this over to, why is it being so finicky? All right, can we just imagine, I'll just, you know what, it's fine. Crisscross applesauce, 9, we're doing 10 and 11. Okay, So this is the same thing we had before, but now we're changing it to have a second LED. So instead of calling it LED, let's call it blue or red and green. Red is connected to 11, and then green is connected to 10. All right, and it's, I mean, we can keep it as green just so you can see where it's going. That's fine. Green is 10, 11, and same thing. We gotta pin them. Now we gotta remember to change the name because we changed the name. And instead of writing to LED pin, we're gonna write to. Do you guys want red on when you're held or green on? I guess we can do like green means it's ready to be clicked, and then when you click it, it's like danger, or I don't know, make up your own story. So if you hold it, you're gonna turn on the red pin. Otherwise, you're gonna turn on the so you can see like the same thing we did before. Now, just while you hold it, we're gonna turn the green one off. And when you turn the red one off, we're gonna turn the green one off. Now, the first thing I said is keep it just on or off. Then we make it opposite brightness. Like we already just set it up with using brightness, but if you wanna do on or off, you can just do digital right high, digital right low for the green one or red one, whatever you're doing. All right, starting the simulation now. Let's see if we have any problems. So you can see this is full, so it's the green one is ready. I flick this, it'll switch on all the way. And then I'll take this to halfway. And then you can see that it changes the brightness as well, right? So you can see, and then boom. Does this make sense? Okay. Finally, we said make it flicker. You could do this in a few ways. I mean, if we're saying, which one are we saying is the one that needs to flicker? The one that's only on. I'm not sure how fast you want it to flicker. I feel like it's not that important, but I'll change it to the button one. Or here, let's see. Okay, so if you wanted to like just flicker, right? You could. I guess you have to do it separately. Actually, hold on. Let's move it here. So this is delay 10, right? Because you want to be able to read these. And what happens is once it's held, you want to. I'm just trying to remember which one because these are crisscrossed. When it's held, you switch to red. And what we're saying is while red is held, we want green to turn on or off, on and off. When we let go, we'll just keep green this way. I mean, you could do it a few other ways, but I guess what I'm understanding now, make it opposite brightness and flicker. I guess it could flicker while it doesn't matter. So we'll just do it while red is on, green is gonna flicker. When you let go, only green is gonna be on. Is that good? Make sense? Okay, so while it's held, instead of turning green on or off, we're just gonna turn, okay, so the simple way we can do this is just do what we've been doing before. We can actually change this to digital, oh, it's simulation, that's why. We can just, if we want it to flicker, like all the way on, all the way off, we can just do digital right. Now the issue here is you need to in some way delay it, right? And I don't wanna make it too code complicated, so we'll go through a simpler way. So for now, we'll just add a delay and see how that looks and if there's any issues. So while you're holding the thing, you're gonna flicker this on and off, and we're just gonna do low and high just to show you that you can use both. Okay, so this, I hold it. You can see green is on, off. Oh, there should be another delay after, that's why. Okay. Hold, and it just flickers. Yeah, for 1 second, off. Now I'm gonna let go, and it's just gonna be green on. The only issue is because we're doing this delay, this is not immediate. And you can get around this by spreading it into, like, essentially, you'd have to keep track of time separately. Like if you know that delay is 10, you can keep track. The easiest way is without using extra modules, is to have a counter. I just don't know if I wanna get you to the next challenge yet, or practice. So you could have, like, if you were to do this, I'll just do it quick. You have the counter for how much time it's been, and you could do like C++, which just means, it's the language. It means it's been one loop, so it's been 10 seconds. And while it's held, you could determine whether or not to turn it on based on if this is like, if you can divide it by 100 or not. If you want to make it like the exact time, you can, just to keep it consistent with milliseconds, add 10 instead of 1. And then what you do here is you do, where is it? Digital, right? Instead of this, you can say C divide, like you can, I'm trying to remember in, I'm just trying to remember how C++ handles that. So you want to essentially only write it based on the counter. How would we don't want even or odd. Just trying to remember what I had in my head because I don't want to make it too complicated. All right, challenge to the viewer. What do you think I should do? Because my brain is malfunctioning. How do I make this only on for 1 second and off while still here without any delays based on this C counter, which is remembering how much time it's been since we started. So ideally, like, we want to remember how long, if you wanted to like immediately turn on, it might be a bit more complicated, but you'd have to have like another counter here for like when the first moment you held it is. Well, we can just keep track, like if it's an even second or an odd second. So you could check like in seconds based on C divided by 1000. And then you can say that if it's an even second, you do that. So we can just, we'll just keep it simple without adding more than an if statement. If seconds, if the remainder, like when you divide it by 2, is 0, that means it's an even number. And then we'll just do digital write. Fine. Now, what you'd actually want to do is you want to have a second counter for when you started and subtract from these two counters, and that'll make it where immediately when you click it will turn on. I just don't want to take too much time because I feel like we're running behind a bit. Digital write, green pin, low. Does this make sense as to what we're doing here? So it's a bit, it looks a bit more finicky to add this last bonus, but what we're doing is what we had before, but instead of just turning it, like when we start the simulation, assuming this works fine, when nothing is happening, this is on. And when I click this, instead of doing it where the red is on and the green is off, we're doing it where the red is on based on the brightness. So if I lower it, it's barely going to be on. And if I turn it higher, it's all the way on. And we did this by reading the potentiometer, right? Brightness divided by 4, and then just writing it while it's held. If it's not held, we just write it as 0. Otherwise, we can control the brightness by seeing the green pin when it's not held. When it is held, the green pin will flicker. It will be all the way, so it doesn't actually care about the brightness because we did digital write. Does this all make sense, or is there anything confusing about this? Let me know now. All right, can I get a thumbs up if it makes sense to you? We got a laughing emoji. Very quirky. They took it off. Okay. Let's go to the second practice now. So this is the one I expected to take more time, but I guess I was a bit too slow on the first practice. So it's good if it's thorough, if you guys get it. But that makes sense. Let's do the second practice now. And this one, I want it to be a bit more open-ended again. I want you to try your best to learn RGB button on your own. I'll tell you, it's a bit simple. Like once you put it in here, like if you read the pins, like I guess that's my hint. If you read the pins, you'll know what they're supposed to do. But do, instead of an LED, do an RGB. If you remember how like colors work in Python or whatnot, or if you're a painter, I guess, RGB is like red, green, blue. How much of each component determines the color you have. So I want you to use that for the Arduino. Just see if you can get it working. I put a link for something. I don't actually know if it's great, But yeah, Google, just because that's what you'll be doing, like learning components on your own. And then after it, we'll go over this example where you control the light with buttons, one for red, one for blue, one for green. And then we switch it to potentiometers instead. And it's just, there's a lot of wires, so you got to be careful. And if you've done all that, you can start working with like a buzzer or whatever components you want. Okay. And I guess we might be running more time than I thought for this, but that's fine. Like these are meant to be flexible just as far as we go. So if you're really ahead, you can start working on the LCD display. I don't think we're going to actually get to it this workshop just because I expect this to take 30 minutes. So I'm going to mute now. Let me know if you have any questions. 10, 15 minutes again. Welcome back. I guess I'm welcoming myself back, which is always good. How are we doing? Give me a thumbs up if you figured out how to wire an RGB LED. Thumbs up on wiring it up with no instructions from me, just you and your great ability to Google. Okay, so I'm gonna take it up now because I just want to give you guys a chance to try and figure out a component on your own. But I do want to go to just letting you do your own thing instead of having to do RGB. So let's go through this now. I'm just opening up this thing and let's put a new board again. So we have this. Hopefully I still have your attention. And we're gonna do LED again, but you'll notice down here, just moving my camera away so I can see it. We have this. And if you look at this, it tells you green, blue, red, and right here there's a cathode, which if you remember our diagram, cathode is where the electricity exits. So it enters through the anode and out the cathode. So if this is the cathode, where's the anode? You type in chat because I'm waiting. All right, I'll tell you guys, but let me see a raised hand reaction just to see if everyone is still here. Oh, we got some praise. Thank you. All right, more than half, so that's good enough for me. All right, essentially, the cathode is where it exits, so that means it wants to go to the negative, right? That's all that matters to us. What we care about here is blue, green, and red. We actually are gonna put a resistor anyways, so instead of putting a wire, I'll just put a resistor again. Oh, there's people in the waiting room. Someone named themselves MasseyHacks. I hope that's actually an organizer, not some impersonator. Okay, so that's the cathode, and it's gonna exit at, I believe, the same resistance, although I could be wrong because my memory has proven time and time again to not be reliable. Okay, so green, blue, and red, those are the anodes. That's where you give electricity. And if we just try, remember, like no code, just the battery, we just gave them all power, what color do you think, what do you think is going to happen here? So everything is on all the way, then there's a resistance of 220 ohms down to the ground, which is just like connecting back here to 0 volts, which is why there's a circuit. What do you think is going to happen if I run this? No wrong answers. Well, there's wrong answers, but I won't make fun of you too much. Oh, none of you are brave. Start simulation. Wait, exactly. Because the full RGB, if you put all of everything, it is white. So that means if I give it full power, so this is the same as giving it digital write high, because that gives it 5 volts. What I'm giving it is just 5 volts for all of these. And that is white. Which also means that if I give it nothing, well, then there's no power, but if you give it something, let's go here to the code. You want to be able to extend it code first, so you need to change these. And again, since if we give it all the way, it's white, we don't want to only give it all the way. So let's use the PWM. So this is, I'm trying to find the squiggly lines. 3, 5, and what's this? 9. All right, let's put it over here so it doesn't overlap with our diagram. Okay. So now what we're gonna do is we're gonna control the light. So someone give me a light, like some RGB combination they like. Or we're gonna go to the color wheel and find out ourselves. I'm just trying to move the chat again. Okay, so now, remember how we had red pins so on for, single LEDs? We're gonna do it for one LED, but it has 3 different pins that control how much of each color it has. So the red pin is connected to 11. Sorry, someone have a question? I heard someone unmute for nothing then. The blue pin is, what was it? 5. And that means green, RGB. Although blue is here, green is here, 4, 3. I'll just move this up here so that it's like RGB because we're cool. And we're gonna make these ones all output because we're telling it how much electricity to control the color. Okay, so now we pinned it all, and let's just make a color for now. So let's just do nothing but digital. Let's just do digital, right? Let's turn on a color. So we're gonna turn red on and the other two off. Green, blue, green pin. Okay, so now if we try this, I'm hoping you have an idea of what will happen. It's red, woo! Good for us, aren't we cool? Now what we're gonna do instead is instead of just turning it on for here, I mean, you can tinker with it. You can say, turn on red and green, and if you know your color wheel, you'll know that'll make yellow. I didn't know, so I just waited. Okay, but instead of digital right, you could also do analog right. Now, since we said in the challenge, figure this out, this is all you really needed to know, like how to turn it on. The next part was using buttons for it, one for red. So we'll still use digital for now, but then after I will switch it. So let's add a button now to the side. And if I'm confusing anyone, let me know. So again, same thing we did before. We will turn the button on. We will ground the button. And we can do that again with you can connect it to a different row and have a resistor, or just, I mean, same row if you really want, but that's not doing anything. But the easiest way is just, it keeps rotating. All right, just ground it immediately. And remember, we want, for buttons, 10K. You'll notice the colors change, which is kind of cool. Finally, we need to read if the button is pressed or not. So we are gonna have, let's just do that 0, sure, we'll just label that like green for now, okay? Now, if we just did this, right, and we just had button pin is equal to 0, and we pinned that, as input, so we can read from it. Since it's digital, it doesn't matter if it's on the thing or not. We can just see if it's held, turn on the color, which in our case is, what is it called? Green, blue, whatever it is. If pin, what's it called? If, and we want to see if, what is it? Digital read of our pin, which is just button. So if it is held, so if you're holding it, give this color. Does that make sense? Otherwise, we can just do, and again, we can change the delay down so that it reacts faster. Otherwise, let's just turn it off. I don't know if it'll turn to black or off because you're not giving it any power. I don't know if there was supposed to be a way to turn black, but yeah. If digit, what's happening here? Oh, it's because I didn't change what I did. If digital read button pin is equal to high, what's happening? Is it the button pin? I'm not a little unsure on why it's. Did I mess up the voltage? 10K. This is the same wiring we did before, right? I didn't use a different one. No, it's just resisting and it reads. We could, it might be the pin I used is some weird one. Just use 2. Otherwise, we pinned it as input, and then if we read it as an integer, and the value is equal to high. Okay. I think it was just the pin number, but don't fear yourself too much. Okay, so here we hold it and it turns on, then we let go and it turns off. And it's pretty fast, like the delay isn't that fast, but since the delay isn't long, it reacts fast. Well, because it's an RGB LED, sometimes it takes longer to turn off. So I just clicked it there. And what we want to do is we want to do 3 different buttons to control 3 different RGBs. Does this make sense so far? Because now it becomes more an issue of not code, but wiring, just like trying to organize it. So you might, this is usually when you might want to move over to like a bigger breadboard. So you can, there's like, you see those, the larger breadboards down here. I don't know if there's one that's already wired to a long one. I guess we've been using, have we been using? Where is it? Yeah, so no, you would wire this, and it's the same thing, just longer. Like you see how all this is attached, all this. I don't think we need it yet. We'll just have to be a little careful with our wiring. Okay, so let's get rid of the wires for a second. Let's move things over. And these, like this has to be like we need the PWM ones for this, so we're still going to keep here. I'm trying to just keep this like not looking weird. Okay, so this will control the light by doing, I'm just keeping it on the PWM because we want to switch to N, like the, what did we want to do, potentiometers? Although there might not be enough time for that. So I'm keeping you on PWM for those that got that far, but we're just doing the buttons. And I'm just trying to set it up more of like a walkthrough, but if I'm going too slow, let me know in the chat. If you want me to just speed up so we can just show you the potentiometer. I'll keep the chat open here. Okay. Now what we want to be able to do is we want to read all these different ones. So I'm going to read from them. I'll just set up 2. This one, we'll set up to 3. And again, these ones, you don't need to worry about PWM or not because they're going to be digital. So we have 2, 3, 4. And all that matters is each of these need to have the resistance on the way down. And they need power. So this is getting a bit messy with the wires, but it's actually not as messy as the potentiometer. I guess because then, you know, potentiometer has the on, off, and then reading in the middle. Actually, that one would be less just because it's by itself a resistor, so you don't have to worry about it. Anyways, let's just change this quickly. So I'm just going to run through this. 2, 3, 4. Essentially, we're changing the pins to have 3 different pins for buttons because and you want to pin them all as input, and you're just reading digital. Pin 2, pin 3. And then you want to read from them all. So you can just say, like you can just call this like red. Say the first one is for red, next one is for green, and next one is for blue because RGB. 2, 3. Green, RGB. All right, does this make sense? So this is telling you if you're using green, I mean red, green, or blue. And then based on that, you're just gonna write the color of it. And then I guess you could have the delay is based on how active you want your colors to be. Now this is gonna be just 3 colors because you can't hold more than, like, you can't use your mouse to hold 2 at once, but in real life you'd be able to control it by clicking 2, and based on the 2 it reads, it'll have like an in the middle color. So not just red, green, and blue. So you can say you're gonna write to the red whether or not red is held, green whether or not green is held, and then blue, whether or not blue is held. And that way you can control it with 3 buttons. Does this make sense? And then you can turn them to like clicked instead if you want to. See, now this is red. I'm gonna turn it off. This is what is this one? 2, 3, 4. 2, 3, 4. Button. Digital write, red pin, red. Did I mess something up here? So this is 4. I'm not entirely sure why this is. So this one is red, which is the first one. And we made, oh, did we change them around? Yeah, we changed them. Okay, so we want the red pin to be 11. The blue pin to be 10. Yeah, just remember how we rewired. You got to remember something. Oh, what is this? Okay. So the blue one is 10. Oh, it's because in the simulation, so it was being weird. 10, and then green pin is 6. Okay, does this make sense to everyone? This is where you let me know if you have any troubles, because I think this should be fine now. So blue, green, red. And you notice how sometimes in the middle, I think it's just like, because we immediately turn it off, right? If you're not holding it. Or it might be acting weird because of the wiring of the buttons. It might not immediately realize. I have to look into the differences again. Okay, does this make sense to everyone? Thumbs up if you're still with me. Thumbs up if you're with me. Well, we got more laughing emojis. Type in chat if you have any issues, any questions. What I'm gonna do now is I'm gonna tell you just, we don't have as much time as I thought we would. I mean, I kind of went slow because I thought we have this much time, but I do want to let you guys off on time. So now we're going to go to this last part, but I'm also going to spend this time to show you the potentiometers. So for those interested, just leave and come back if you want. I'll try to go through this at the end, although we're already at the end. Just make LEDs, make some nice display, and then we can see them at the end. If you make something cool, I mean, I guess I'll open it on here, so hopefully something cool. If you do want to go another step, try to figure out the LCD display component. It might be a little confusing to figure it out on your own in 20 minutes, but give it a shot. There's also the piezo, that's just a buzzer if you want to try it. And I'm going to show you how you would turn it from buttons to potentiometers, okay? But just like, if you don't want to hear that, if you just want to work on some light display, feel free to do that as well. And hopefully one of you will have some light display for us, which would just make something that looks cool, or anything really. Okay, let's go and change these buttons to potentiometers. And because potentiometers are by themselves resistors, we don't need these resistors. And all we have to do is potentiometer. And do you remember how there was the reading? Now these are gonna have to go to the A pins. So we can do like A0. Just to keep it consistent. And then we can have another potentiometer, or I guess let's turn it to 10K first, just to keep the resistance up. Potentiometer, this one, we will have an A2, just so we can read it. And this one, we will have in A3, or I guess that was A2, this is A1, okay. So A0, A1, A2, and finally, we're just gonna go around these, so. Okay, does this wiring make sense to everyone? So this is just what we had with the buttons, but instead we changed it to potentiometers. Because it's analog in, we had to use these pins instead. And these are by themselves resistors, so we put 10K and called it a day. Okay. Now we're going to go back to the code, and instead of doing buttons, we're just going to do potentiometers. I'll change the name just so you know. We also have to change the pins. So if you have questions, just let me know. I think someone is unmuted. And remember, these will read from 0 to 1024. So all we're doing now is we're pinning them all. Instead of these, we're pinning these. So this just knows if it's sending electricity or receiving electricity and measuring it. Instead of knowing the red, we'll do red is analog read, lowercase. And we'll read it from the first potentiometer. You can name it something, else. But we will also divide this by 4 again, so that we can get it in something we send to the RGB. Because in digital, right? Remember how we put these on the PWMs or analog, right? Technically, that'll be 0 to 255. And we're just doing green and blue. And so we've already had this set up like where we read, like we write red, green, and blue. It's just that this used to be low and high. Now it's reading an integer between 0 and 255. The only thing is we have to change this to analog so that it can actually send that. And we've already pinned a PWM pin to the output. Does this all make sense? If you have any questions, let me know. And we're just going to test this. So it's being a bit. Did I do something weird? I must have done something weird. Am I missing potentiometer? Hold on. So I read based on what we read. This is A0, A1, A2. How did we wire this before? Power, off, and read. And again, for analog read, you don't need to pin it. I just did for, just to stay consistent. Why does this give us some weird values? So if I turn them all on, does it understand that? Because sometimes it'll send weird amounts of power back in. This isn't being, is it because of the, oh, is this the wrong one? No, that's right. I'm not sure. I'm trying to figure out if it's one of these problems. Does someone see what I messed up here? So we pinned these 3 as input and these 3 as output. And we gave green, red, and blue the power to control them directly. And this is reading from 0 to 1024. This is where you'd want to say, oh, I'm not sure what's going on. Serial.begin 9600. And let's increase the delay again since we want to be able to read what's happening. And let's just read one of them for now to see what's going wrong. A0, A1, A2. Oh no, it's because one of them is A3. Okay, so you see what we did here? We used A3, which is something that's not connected to anything. So it's just being some unstable number and skewing off our numbers. So I believe if we change this, it'll work. If not, there is another problem as well. There it is. See, this is all the way up. It's white. I'm going to control, turn this off. It became yellow. I'm trying to see if I still have the right resistance on them. I do not. Okay. Potentiometer. This is yellow. This is changing the brightness. Right. Like if we turned, that should be white. Why is it taking a while? Oh, it's because we did the delay 1000. We forgot to change it back, so it only checks once every second. So it's not that responsive anymore, which is why we can slow it, or I guess speed it up, so that as I do this, you can see it changes colors. And I can put it like, back on, turn this to somewhere in the middle, and come up with any colors I want. Okay? Does this make sense? Everybody good on this challenge, or practice, I guess? This is where I once again ask for, yeah, I'm not doing that again. Just give me a thumbs up. All right, this is also where you ask questions, because we're getting closer to the end, last 20 something minutes. You were supposed to have like a breakdown here, but I guess these took longer than I expected to go through the solutions. Which is also on me. I think my brain short-circuited on a few of these while I was fasting. Okay, I didn't get that many thumbs up, so I don't know how many of you are still here. Thumbs up if you're good, and like high five or whatever this hand is if you are here but having trouble. This is still running in a simulator. I should probably stop it. All right, well, I'm gonna assume those of you that didn't respond are just working on some really nice light displays and having the Zoom muted and not playing League. Okay, so now we're here. If anyone wants to get to the LCD display, let me know. I don't think we're gonna have time for this, just because that I expect it to be like another lesson on the end. So what we'll do instead is I'll just give you guys this time. I'm here for questions, but I just want you to be a bit more creative in the last 20 minutes. Make some LCD light display, maybe like Christmas lights or something. And if you do want to see the next step, figure out the LCD display, here's the tutorial. Just because I want you to get used to playing with these components on your own, because there's a lot of Arduino components. Like if you want to buy like a kit from like Amazon, I bought mine a few years ago. I don't know how expensive it is now. It was like 40, 50 bucks. And then it just has a bunch of different things you could try. And then you'll work on the challenge throughout the week to try and combine as many as you want. Okay, I'm gonna give you guys, what is it, like 15 minutes, and then you're free to go and come back. You're also free to just mute as you have been. I'm gonna mute myself. Just give you time to do whatever you want, essentially. Make something cool, and we'll take it up in the last 10 minutes. Welcome back. We have about 10 something minutes left on the schedule. I guess I just said join back in the last 10, so we can wait a bit. We'll make this more of like a Q&A session towards the end because, you know, we're pretty much here. How are we feeling about hardware? Comment below. I haven't actually done hardware in a while. I'll be taking a hardware course in the summer, but I haven't done it since the last time I was at this workshop. So it's just a struggle because everything is like, my kit's in Windsor and I'm doing the work here. All right, wave at me if you're still here. Wave. I got a high five or a hand up. I think there's a different emoji for a wave, but that's good too. 4. I'll take the 4 of you that are here. So if anyone has any questions or anything to share, feeling pretty good, yeah. I wasn't sure what to cover here because I wanted to get people that didn't have until this point, like any knowledge to go thoroughly until this point, but I also wanted to give you guys enough things to try. So I tried having the challenges have a little more depth. Or I guess the practices, because you guys have challenges as like a keyword. Yeah, if you have any questions in general, Toronto, I know you guys are all trying to get into Waterloo if you're in CS, or I don't know, maybe you're just more of a hardware person, or is this open to non-Massey kids? I don't remember. I don't know how much they changed it. Yeah, I don't think we have enough time to go through the second. I guess we already went through this. I mean the LCD. I could post. I guess there's already the tutorial I sent on here, but I don't know how useful it really is. Let's see. Data pins. I think it looks pretty thorough. Essentially, to get started, you could just use the 4 of them, and the reason they're like in different colors, it decides like how many bits you have. Like this is just a screen, right? And you can tell it like what to display on each screen. So you could have like you could put like text in there, or you could control it more like directly. And by controlling how much what you send to these pins, you control essentially it becomes like 4 bits or 8 bits. And these are just like, you know, anode, cathode, and ground, and extra stuff to read, right, whatnot. But yeah, you just have 4 of these pins if you're getting started, and I think they'll have the layout somewhere here. But this is pretty thorough, so you can follow this link if you're interested. It's on the intro slides. I'll paste that as well. For those of you watching, I don't know, in the future for whatever reason from YouTube, it's also pasted on Discord, maybe on the YouTube, who knows. So I'll put it in chat. That's the intro to Arduino that you're already on. And over here, you should be able to get to the LCD. It's probably going to take you more than 10 minutes, so we're not going to get into it. But if anyone has questions, they want to show us their light display or ask more general questions, let me know. In about 9 minutes, I'm just going to end the meeting. So this is your moment to shine. Okay, I don't think anyone is joining back here, or the ones that did already got admitted. Yeah, you're heading now. See you later, Noah. I'm gonna end the meeting shortly. Just want to say thank you all for showing up, staying through it. It's pretty long of a workshop, so I try to be thorough around. If you have any questions regarding anything, let me know now. React how you're feeling. Give me a thumbs down for if I did a bad job, so on. And I'm tell you all, you're free to go. All right. Have a good night, everyone. Enjoy your weekend. And for those watching later, I don't know, hopefully you submit something.